Question 10. A boy throws a stone with a speed of u meters per second from a point at the top of a cliff. Now the cliff is 18 meters above sea level and it makes this curve and lands in the sea. We've got to find out what our u is if it lands 36 meters from the bottom of the cliff. So what I've done to start is I've drawn my version of this diagram here. I'll put u on there. Acceleration, it tells us that gravity, we've got to use g as 10 in our question, so I'll put that down there. What we need to use now is our alpha. So we're told that tan alpha equals 3/4. So like in other questions, we draw our right angle triangle, alpha, opposite over adjacent. So this one must be 5 because of Pythagoras. So sine alpha is going to be opposite over hypotenuse, which is 3/5, and cos alpha equals adjacent over hypotenuse, which is going to be 4/5. Now, using our diagram, we're going to set up two equations of motion. So the first one is for our horizontal motion. Now what you need to know about horizontal motion is that the acceleration is 0 for this type of motion. So our equation of motion is just going to be S equals, it's going to be our u component, so it's going to be u cos alpha. If we look at the diagram, it sets off at u, but it's the side that's alongside here, so it's adjacent to it, so it's u cos alpha times t. So what is the distance that we travel? We travel 36 meters, so we get 36 equals u times our cos alpha is 4/5, and how long does it take us to do that? We haven't worked that out yet. We've got our t. So we've just got an equation. We can rearrange this. I'm going to rearrange this to get t in terms of u. So t is going to be 5 times 36 all over 4u. Now if we cancel this, that's going to be 36 divided by 4 gives us 9. That's going to be 45 over u. And that's our value of t. I'm just going to call that number 1. Now the next thing we're going to do, we're going to set up an equation for vertical motion. Now we're going to need our suvat variables, S, U, V, A and T. So if I write those down there, and now we'll refer to the diagram. So our S is going to be, we're going from there at the top of the cliff down to the bottom. S is going to be minus 18. We're dropping down 18 meters. What's our u going to be? Well, it's going to be our vertical component of u. So our u, when it goes up, is going to be u sine alpha. And sine alpha was 3/5, so it's going to be 3/5 u. What's our v going to be? We don't know that at all. What's our a going to be? Well, this is opposite our motion because we've set this as the positive direction going upwards. So it's going to be minus 10 meters per second to the minus 2. And our t, we get this from over here, from our horizontal component. The time to get there is 45 over u. So that's where that comes in there. So which equation are we going to use? Well, we've not got v. So the equation, you need to learn these quite well for the exam. You need S equals ut plus a half at squared. And we're going to substitute the relevant things into there now. So our S, we get minus 18 equals 3/5 u times our t. Our t is 45 over u plus a half times minus 10 times t, which is 45 over u squared. So tidying this up, minus 18 equals, well, what's that going to be? 45 divided by 5 is 9. 9 threes are 27, and the u's cancel out. That's just going to be 27, that term there. And then better do this one on the calculator. It looks like it's going to be a bit bigger. So I've got 0.5 times minus 10 times 45 squared equals. Now that gets me minus 10125 all over u squared. Okay, so if I bring this u squared term over here, I will get 10125 over u squared equals 27 plus 18. So 10125 equals 45, and then we've got u squared under there. So if I cross multiply, I'm going to get 10125 over 45 equals u squared. So u is going to be the square root of 10125 over 45. So if I do that on the calculator, so we've got square root fraction 10125 over 45 equals, and that comes to 15 meters per second. Part B of the question asks us to find the speed of a stone when it's 10.8 meters above sea level. So if you think 10.8 meters above sea level, if we take 18, which is our height, take away 10.8, it means it's actually dropped 7.2 meters. So I'm going to make our positive direction as going upwards again. So our S, our displacement, is going to be minus 7.2 meters. U is going to be 15 sine alpha. So that's 15 times 3/5, which is going to be 9 meters per second to the minus 1. V we don't know. Our A is minus 10 meters per second to the minus 2. Now we're trying to find V. So the simplest equation to use is going to be V squared equals U squared plus 2AS. So V squared is going to be U squared, which is 9 squared, plus 2 times A is minus 10 times S is minus 7.2. So if we do that on the calculator, we should get 9 squared plus 2 times minus 10 times 7.2, and that gets us 225. So V is going to be the square root of 225, so that's going to be 15 meters per second to the minus 1. But this is the vertical component of the speed. What's the horizontal component? Well, it's going to be 15 times cos alpha, which is 15 times 4/5. 4/5 of 15, which is 12 meters per second to the minus 1. So the magnitude of our speed then is going to be the horizontal squared plus the vertical squared square rooted. So that's going to be 15 squared plus 12 squared, all square rooted. We do that on the calculator. We get 19.209. They asked for it to two significant figures, so that's going to be 19 meters per second to the -1 to two significant figures. Part C asks for any improvements, two improvements that could be made to the model. I've just included 4 here as an idea. Include air resistance, use more accurate value for G rather than 10, include wind effects, include dimensions of stone in model. So any two of those would be okay.